All right, guys, this is our last Electrochem Chapter 20 video. I will say in the PowerPoint, the first video took us up to the slide where we start balancing equations. That's what we're going to practice here. And then after balancing equations, the material gets into talking about batteries, lead-based batteries and stuff like that. That's interesting information, but generally it is not covered in our material. So in the PowerPoint, if you go through the sections that cover balancing equations, maybe breeze through just the general setup of a battery would be a good idea. But beyond that, I think it's a good place for you to quit for the chapter. Anyway, I have three equations that we're going to practice on, balancing equations. I'm going to start with the bottom one and work my way up. So first reaction is iron plus 2, reacting with permanganate to give iron plus 3, and manganese with a plus 2 charge. So if we follow our steps that we have to follow for balancing redox reactions, the first step we have is writing a half reaction, balancing it, then we write the other half reaction and balance that one. Okay, so we're going to start out with, I'll do the iron half reaction first. So basically what I see is iron plus 2 is going to be converted into iron plus 3. So I'm going to write that as a reaction by itself. Fe2 plus yields Fe3 plus. So as we go through the steps, first step of the procedure that we follow is balancing the non-oxygen or hydrogen element. Specifically, it's just, oxygen and hydrogen can always be balanced using components of an aqueous solution. The other elements have to be dealt with first. In this case, obviously, iron is a different element from oxygen and hydrogen. So I have one iron on the left side, I have one iron on the right side. It's already balanced. I don't have to do anything for that step. So then I move on. The next step says I need to balance oxygen by adding water to whichever side I need to. Well, if I look at this reaction, there is no oxygen. So again, I can skip over that step. The next step says balance hydrogen by adding H pluses to either side. Again, I don't have any hydrogen, so I can skip over that step as well. Finally, I get to where I need to balance the charge by adding electrons. So I have to look at the charge on both sides of the equation. On the left side of the equation, the total charge is just plus 2. On the right side of the equation, it's plus 3. That's a difference of 1. I'm always going to add the electrons to the side that has a higher charge. Since electrons are negative, they're going to bring the charge down. So I'm going to bring this charge down by 1, adding 1 electron. So the charge on this side is now plus 3 minus 1. It's going to be positive 2 on this side to equal the positive 2 over there. So always add the electrons to the side of the higher charge to bring it down until it's equal to the low side. So that's the end. I've balanced that half reaction. That was a really easy one because there wasn't much to it. Now we'll do the other one. Permanganate is going to turn into manganese with a plus 2 charge. So I write that out. MnO4 minus is going to become Mn2 plus. So this time I go through my steps again. I balance the other element, and get this case to be manganese. One manganese here, one manganese here. It's already done. Go to the next step. I'm going to balance oxygen by adding water. So when I look in the reaction, I have 4 oxygens on this side. I don't have any over here. So I'm going to add 4 water molecules. Each water molecule has one oxygen in it. So I add 4 water molecules. So now on the right side of the equation, I have 4 oxygens. On the left side, I have 4 oxygens. Next step, I got to balance hydrogen by adding H pluses. I have 8 hydrogens right here, so I need to add 8 H pluses to my left side. Now, once I get to this point, this is where a lot of students would mess up. When I look at the charge on the left side, I have to recognize there's a minus 1 on the permanganate, there's a plus 1 on hydrogen, but there are 8 hydrogens. So that's a positive 8 right there, minus 1. The charge on the left side is plus 7. The charge on the right side is plus 2. I add electrons to the high side, so I'm going to add 5 electrons to the left side because I want to bring that plus 7 all the way down to plus 2, which is what I had over here. That way the two sides have equal charge. So at this point I know in order for permanganate to be reduced to manganese +2, I have to add 5 electrons. It kind of makes sense if I actually assign the oxidation number of manganese here, it's +7. Manganese here is +2. The only way manganese can go from +7 to +2 is by getting 5 electrons, okay? But we went a much more in-depth procedure to get to that. So I have my 2 half reactions are now fully balanced. The last step I have to go through is I'm going to combine these 2 half reactions, but I have to make sure the electrons are going to cancel, meaning the electrons being released by the first reaction have to be enough to satisfy the electrons that I need to gain on my second half reaction. So I have to match those numbers up. So I'm going to have to find the lowest common multiple between the electrons here and the electrons here. The lowest common multiple between 1 and 5 is 5. So I need to have 5 electrons in both reactions. That means the first reaction, I'm going to take the whole balanced equation and multiply it by 5. So I'm going to distribute that 5 all the way through. So when I do that, it's going to be 5 Fe plus 2s, 5 Fe plus 3s, and 5 electrons. Now I can combine them. One thing to note, whenever you have your 2 half reactions, the oxidation half reaction is the one that's losing electrons. So up here we could have said iron going from +2 to +3, charge going up, that's oxidation. In my half reaction, that means the electrons should be on the right-hand side for the oxidation. If I look at the reduction half reaction, it's gaining electrons. So it's got to get electrons from somewhere else, and I'm adding them into what I have. So it's a reactant. When you have 2 half reactions, it has to be an oxidation reduction. They can't both gain, they can't both lose. It has to be one of each. Okay? So I've equalized my electrons on each side. I'm going to add everything together. So when I get my overall reaction, I'm just going to list everything on this side. It's going to be 5 electrons plus 8 H pluses plus 5 Fe 2 pluses plus permanganate, MnO4 minus, yields 5 Fe 3 pluses plus Mn plus 2 plus 4 waters plus 5 electrons. Now once I have all that stuff, now I look for anything that shows up on both sides that I can get rid of. The electrons should always cancel out. So I see 5 electrons over there, I have 5 electrons here, they're going to cancel out. Commonly, there are a lot of times when you have your half reactions, you're going to have waters on both sides or hydrogens on both sides. In this case though, I have H pluses over there, I have waters over here. There's really nothing else to cancel out. So my overall reaction is going to be everything that remains right there. That is our first balanced equation that we've done. Okay, so now we're going to clear and move on to our second reaction. Again, I'm doing the three redox reactions that are listed in the PowerPoint. One of them was on the slide with all the rules, and then the other 2 are on the next slide. So I'm doing hydrogen peroxide plus dichromate yields chromium plus 3 and oxygen gas. So again, I'm going to write my 2 half reactions. I'll do the chromium one first. Cr2O7 with a -2 charge yields Cr3 plus. And so I follow my rules. In this half reaction, I'm going to balance chromium first. I have 2 chromiums over here. I have 1 over here. So I need to put a 2 in front on this side. Now I go to oxygen. I have 7 oxygens on this side. I have none over here. So I need to add 7 waters. Now I want hydrogen. 14 hydrogens here. So I need 14 H pluses over here. And finally, I need electrons. My charge on the left side is going to be positive 14 minus 2. That makes positive 12 over there. On this side, I have positive 6. So positive 12, positive 6. I'm going to add 6 electrons to the left side. Okay, that's my first half reaction. The other half reaction, hydrogen peroxide yields O2. So the oxygen in a peroxide, the oxygen charge is -1. In oxygen gas, the charge is 0. So that is my other element that is being, in this case, oxidized. Chromium was being reduced in the first reaction. You got to make sure that in your two half reactions, one half reaction is focused on the element being oxidized, the other half reaction is focused on the element that's being reduced. So you do have to kind of know what those two elements are in order to set up your half reaction properly. So looking at this, there is no other element present, so I don't have to worry about it. So I go to oxygen now. I have 2 oxygens on each side, so I don't need to add any water. Then I go to hydrogen. I've got 2 hydrogens over here. I had to add 2 H pluses to the right side. Then I get to electrons. I have no charge on the left. I have a +2 on the right, so I need 2 electrons. That half reaction is also balanced. Now look at the 2 of them. I have 6 over there. I have 3 over here. 6 electrons over there, 2 electrons here. I need to go to the lowest common multiple, which is going to be 6. So I multiply the bottom reaction times 3. So I have times 3. I'm just going to go ahead and distribute it. I'm going to have 3 peroxides, 3 oxygen molecules, 6 hydrogens, and 6 electrons. So I just tripled everything in that reaction. Now my electrons here and my electrons there match. Now I'm ready to put them together. I can kind of shortcut. I could write them all out here, and then cancel things out. I mean, if I'm careful, I can kind of see that's all my reactants. These are all my products. I know that my 6 electrons and my 6 electrons should cancel. Hydrogens, I have 6 H pluses on the right. I have 14 on the left. The smaller one's going to go away. So I'm going to take away the 6 hydrogens on this side. I'm going to take the same number away from over there. So if I do minus 6 H pluses, that's going to, 14 minus 6 is going to be 8 H pluses. So that's what I end up of that. 14 minus 6 is just my math I need to see. Water molecules, I have water over here, that's hydrogen peroxide, so I think that's all that cancels. So now let's write what's left. There should be 8 H pluses plus Cr2O7 2 minus plus 3 hydrogen peroxides yields 2 Cr plus 3s plus 3 O2s plus 7 waters. Now we should double check. We could check all the elements, but honestly a shortcut, if you want to check your charge. If you did it right, your charge should balance. So on my left side, I have 8 positives minus 2, so I have a +6 charge over here. If I look over here, I also have a +6 charge, so I think it's going to work out. I could double check though, just to be sure. 8 hydrogens plus 6 is 14 hydrogens. 7 waters, that's 14 hydrogens. I've got 7 oxygens plus 6 is 13 oxygens. I've got 6 plus 7 is 13 oxygens. 2 chromiums, 2 chromiums. That's pretty much it. Okay, so that reaction is done. I'm gonna have to cut the video off to do the third reaction.